Ngalakin Khadijan Nyunga Boja.
Okay, now in your lab meetings with your lab demonstrator in weeks 2 and 3, you are doing a professional performance analysis. This may seem like something that is not that important, but it will be something that might help you identify something that you haven't realised. I'll speak more about what professional performance is as we go through the example. What's going to happen now is I'm going to go through a case study. I'll give you a little bit of information about professional performance analysis. Then we'll go through a case study that's totally unrelated to electrical engineering, so that you're not thinking about the electrical engineering parts. It's a very simple engineering case study that any of you would be able to understand, to help you understand the kinds of things that we want you to think about for your own projects, but using the same framework. So this is a professional performance is something that's been identified by a centre at the University of Sydney called the Warren Centre. They have identified that there are 3 dimensions to engineering professionalism: ethics, competency, which comes from, in your case so far, your education, and performance. And performance is about how you tackle a task, your attitude towards the task, the questions that you ask in addressing the task. And that's what we're focusing on today. How you go about ensuring that you deliver on the final agreed outcome. There are 8 elements of professional performance. I don't know if you can read those from the back. We'll go into those in more detail in a moment. Considering the stakeholders, making sure that you understand what the task is, making sure that you're competent for the task, identifying the competence that is required, thinking about the public and other regulators who are actually there to ensure that the public is taken account of in your projects, thinking about risk and making sure that you're trying to minimise risk, and planning ahead for risk that might occur, trying to be innovative, managing your project, and finally, I can't read it from here, the contract, which in your case is the unit outline, I guess. The unit outline and also the design brief that you have, but ultimately the assessments identified in the unit outline. So PPIR, that's a slightly longer acronym, is Professional Performance, Innovation and Risk. It's a whole set of documents that define a protocol that's been developed by the Warren Centre, as I said, at the University of Sydney, all about acting in a professional way as an engineer. We're not using the whole protocol, we're just using a simplified higher level version of it, using a template. These slides and the template that we're using have actually been developed by the Warren Centre. This is being used, they're hoping that this will be something that is used by engineers widely in Australia. It's being used with students at UWA now, in this unit, and also now at the University of Sydney. This they're calling the plain English summaries of those 8 elements, really just the high-level titles for them to give you a general perspective on the whole protocol. These are the 8 items that we mentioned a moment ago. I don't think I need to speak to each one of them. I hope. They probably seem quite self-explanatory, but when you actually go into the detail of applying them, there'll be things that you haven't thought of. And hopefully they'll become apparent through the case study and then through your own examples. One of the times when this has been found to be especially useful, the Warren Centre has run many workshops with professional engineers and with companies to help companies help their engineers to know how to perform engineering professionally. And graduates have found it especially useful because very often the experience that they have is that one of their superiors will give them a task to undertake and they don't know even what questions they can ask to try and clarify that. And so it's very helpful to have a framework that gives you justification for asking the questions. very often when someone gives you a task, as I saw with the meeting with the group at Jacobs, the person who gave one of the tasks actually said, I probably haven't thought of all the detail in this and haven't even defined it properly, so please ask me questions. This gives you a framework for asking some of the questions. Gives you the essentials of the performance. It helps you to understand the roles and obligations that you have as a professional engineer, and in order to meet your duty and standard of care. This can be used both by a team, and you're going to use it as a team to understand the task that you've been given as a team. It can also be used as an individual, and you're also going to use it within your teams to understand the individual tasks the individual roles that you're given within your team. Okay, now for the case study. I'm going to read it so that I don't muck it up at all. So, we have an example. Five years ago, an industrial estate was built by a developer adjacent to a residential area and close to a main road in the Belangala Council district. The concrete access road to the boundary of the estate was supplied by the council. The estate has 7 warehouse-type structures of various sizes, some housing a single business and others up to 3 different businesses. The businesses include a Fort Knox-type self-storage centre, light industrial operations, a discount retail outlet and a variety of offices. A number of businesses have weekend operations and deliveries are carried out at various times of day and night. So you can see the purple is where all of those businesses are. You can see the council access road is the vertical one on the drawing, and the main road is the horizontal one down the bottom, and there's a residential area on the left. Now, we're going to be given a task related to this. So here are some more details. The main road has a simple spoon drain. I'm not a civil engineer. I didn't know what a spoon drain is. Does anyone know what a spoon drain is? So I've Googled it. And it appears to be a thing like just a trench, a concrete thing like this, next to the road, sometimes with a grid over the top of it. So, the main road has a simple spoon drain on either side. The design for the access road included a standard 200mm diameter concrete drainage pipe to connect the spoon drain on either side of the access road, which drains into a nearby creek. You're going to be asked to design this drain that goes underneath the access road. I'll jump ahead in a moment to what your task is. With no drainage under the access road, which effectively acts as a dam wall, I better give you a bit more information here, I think. Flooding occurs during heavy rainfall. So this section, the shape that's very uneven, that's where the flooding occurs. Direction of fall is where the land is falling downwards. There's a drain running parallel on either side to the main road, so horizontally in our drawing, and your design task is to put a drain underneath the small council access road, connecting the spoon drain on either side. The flooding causes significant damage on the main road to the traffic speed and occasionally the need to close one half of the road. So there's no drainage under the road, as I said, making it effectively a dam wall, and with heavy rain you get flooding 8 to 10 times a year. Complaints have been received by local residents, motorists and from the State Roads Department, who are responsible for the main road. Now we get to your task. This drawing shows how the pipe is installed as an extension to the existing spoon drain. Following a noisy council meeting last night, the council's engineering manager received a firm directive to fix the problem. At 10 a.m, the engineering manager came to the council engineer, handed over a drawing and said, We have to get this drain installed under the access road up at the industrial estate. We've got the pipe in the store and we can use Sandbrook Civils to do the work. They've got all the equipment and they have a standard contract with us for this type of work. So you are the council engineer who's been given this job. You've got a bit of experience in similar work, but you've recently started work with the council. So you're not familiar with who knows what and how things work. You need to apply the principles of professional performance to plan and then carry out the work. You need to go out to the site this afternoon and organise how you're going to run the job. Going to site is an important thing to do always. And this is the council organisation chart. So we've got the council, the chief executive, the engineering manager who gave you the task, and then the council engineer who's you. Okay, so we're going to apply the professional performance framework. I'm going to hand out the framework. If you would pass them through the room. There are, I'll give you a copy. There are, on the front page there's information about a template for the framework, but then behind that there are 3 pages with templates for the different analyses that you'll be doing, one in the case study today and one for your team and one for your tasks within the team. And also at the back is a page that tells you how this will be marked. And all of this information will be going onto the LMS as soon as I have a moment after this lecture. So if you have a look, I'll put it under the document controller. This is the front page of the handout you've just received. The left-hand column is the column that's the main column for the template. I know you can't read it, but you've got the paper in front of you. The middle column is the framework that adjusted so that you can apply it to your team in your meeting with the demonstrator. And the third column is the framework as you can apply it to each member in your team. So today we're just looking at the left-hand column and the first page underneath that. Have I? Oh, sorry, I think I've made a mistake there. Okay, so for the team, sorry, it's still called the team for the team member, but it's actually for the case study. The second page underneath the front cover. So it's the first page, the second page of the handout. You can use this today in the lecture. It won't be assessed, though. So the first thing for you to consider, and you can consider this in pairs and fill it in, and I'll ask for some responses. The relevant parties and stakeholders in this example with the stormwater drain. I'd like you to write down some examples on your sheet. You can discuss it in pairs, and in a moment I'll ask for some suggestions. I'll give you 1 minute. Okay, some suggestions. Who are the stakeholders in this project? Someone at the back, perhaps? Yep. Sorry? Drivers? Absolutely. The motorists? Yeah. Who else?
Businesses in the residential area?
Absolutely. The businesses and also the people in the residential area. The businesses, the local residents, the council, the contractor, and certainly the driver, the motorists as well. Okay, I'll give you 30 seconds for the next one. I've put in the second column on this sheet a little bit more guidance. How will you clarify the engineering task in this case? If it's not clear to you. How could you go about clarifying the task? "30 seconds, so you've got 15 more seconds to go. Someone from the front, perhaps this time? How might you go about clarifying a task? This is actually a really, really important question. The last thing an engineering employer wants you to do is sit there muddling around yourself, not knowing what you're doing, instead of asking someone. So what do you think you might do?
Communication.
Yeah, communicate with somebody. Who might you approach?
The client, or in this instance, your supervisor above you.
Yeah. Any other suggestions? Maybe some other engineers around you, if there are any. Maybe there aren't in this case. Maybe find out whether there are some previous examples that are similar. That might be a good way to go. Certainly that would be a good idea with your design project. When we get to working through a design, I've forgotten what it's called, what's the next step? There's another assessment coming up that's done in your... not verification. No, there's another one. Oh, it'll come to me. The example that we're going to use there, I think it's design validation. The example that we're going to use there is one where somebody actually died because of how something was designed. And one of the flaws, one of the mistakes the engineers made was they'd never built one of the, it's a gate that we're going to look at, they'd never built one before, and they didn't bother looking at how other people have built them. Well, there's no point reinventing the wheel. Have a look at previous examples. Okay, competence. What are the particular fields of engineering that you think might be important in this project that you would need to have competence in? Maybe just some people calling out from the room. What do you think? What parts of an engineering degree might be useful for this project? Civil engineering, in particular. Any particular topics? Materials. Certainly materials will come into one of the later ones as well. Maybe hydraulics, maybe traffic management. These are by no means exhaustive, but there's no one right answer. There are all sorts of things for you to think of with all of these. And certainly in your projects, I'm sure you're already realising there are particular competencies that you need. If you don't have them, you need to work out how you're going to develop them. Okay, the public and the statutory regulations. Any ideas about which ones might be relevant in this project? If this was in WA, who might have some regulations that you need to take account of? Main roads. And the public, members of the public might be the people who are using the road, who we had mentioned at the back before, as well as the providers of utilities who might be affected by the work that you're doing. And this might not seem relevant to electrical engineers, but I assure you it is very relevant to electrical engineers. I did my vacation work, some of my vacation work with Wood and Grieve, and they had been developing the towers, the light towers at the Wacker at the time, and that was affecting the road users who were approaching the road. They were finding that the glare was shining in their eyes and they had to think about that. It also cast a shadow over the Trinity College cricket pitch. So there are lots of things that are to do with the public that you need to think of that you might not realise are important even as an electrical engineer. And some of these regulations, when we had the meeting at Jacobs with the team working at Jacobs, one of the students very sensibly asked why we were using the particular software, why they will be using the particular software that Jacobs is asking them to use, and Jacobs said it's because BHP has mandated that this software will be used everywhere for them, people who are doing work for them. So these things are very relevant to even maybe whether you get the job. Okay, risk management. What do you think could be risks that need to be considered in this particular case? What could go wrong? What could be affected? What could affect the progress of the project? Weather, absolutely. If we know that if there's heavy rain, everything floods, that could affect the project. Anything else?
Traffic in and out of the industrial estate?
Absolutely. Especially, yeah. They need to somehow manage things so that the traffic isn't too affected, but if the traffic is very heavy, then that could make it too difficult to do that very easily on some days. Those things were identified here as well. Has anyone thought of any things that could either affect the progress of your project or could go wrong with your project already? I've seen some. Students have withdrawn. Great. What else? Has anyone seen some things that you're going to have to think about mitigating the consequences of?
Meeting times.
Yep. You're going to have times when people have assessments, they have heavy loads, and it's going to be tough. And so you need to have strategies for dealing with that. Okay, innovation. What sorts of things could you do? In this case, it seems a really simple example. It's putting a pipe under a road. Could you be innovative in any way with this one?
Maybe something above the direction of the ball, like, I don't know, if you can access, because suddenly you can change the direction of the ball.
That sounds very innovative to me. I think maybe it was you, Elizabeth, who mentioned earlier the materials engineering, alternative construction methods, maybe alternative materials. Hopefully you'll be thinking about this with your design projects, although at the same time taking account of things that have been done before because you need to minimise the risk. Task management. Maybe you can tell me how you're going about managing the tasks in your team rather than specifically with this case. What sorts of things do you have to consider? Timeline, yep. How are you sharing? Have you set up systems for sharing files and updating files? Keeping records of which version a file has? All these sorts of things must be considered. Communication strategies, your minutes, all those sorts of things. And finally, this one in our case is the unit outline and your design briefs. And this is something actually, in the case of your projects, with industry-based projects, it is something to be mindful of that the industry partner can become very excited and think of all sorts of things that expand the scope of the project, and you want to please the industry partner, but you need to be careful to remember that your assessments are the things that really matter. If that becomes an issue, then please talk to me, because this is something that is a regular problem with industry-based projects, not necessarily in this unit, I'm not saying, but generally. So that's the most important thing for you is to remember your assessments in your unit. Okay. There are a couple more things about professional performance. I've spoken about how useful it can be for a junior engineer. And just in case you're interested, there's more information about the professional performance framework. Okay.